Hey everyone, and welcome back to our Explainer series. Today we're diving right into Session 5, where we're tackling something absolutely crucial, eliminating process waste and improving efficiency. If you're ready to shift your mindset from, reactive accounting to proactive engineering-based cost reduction, well, you're in exactly the right place. We're going to look way beyond the obvious numbers on a spreadsheet and really dig into the actual structural foundations of manufacturing. Let's get right to it. So I want to kick things off with a pretty serious question. Are your so-called safe operational habits actually draining your budget? This quote really hits the nail on the head. The most expensive loss is the invisible loss that we carelessly pass by. We're talking about the silent budget killers, just hiding in plain sight out on the factory floor. They aren't massive, catastrophic accidents, right? They're the tiny, repetitive inefficiencies acting like an invisible thief, just slowly eroding your margins day after day. Okay, here's our game plan for today. We'll be hitting 6 main points: discovering invisible losses, the 3 types of process loss, the biggest hidden cost, the 3 traits of equipment loss, the balance of risk and ROI, and finally, executing data-driven cost reduction. Let's jump into Section 1, discovering invisible losses, the illusion of the factory floor. When you walk the factory floor, everything might look like it's running incredibly smoothly. Machines are humming, products are moving down the line, but underneath all that hum, structural flaws are hiding. Process loss encompasses way more than just throwing away bad materials. It includes wasted energy and wasted time. This ties right back into lean production and value engineering principles. We aren't talking about isolated accidents or random machine breakdowns here. We're talking about structural issues. These losses happen because of excessive margins set during the design phase, unclear operating standards, or just outdated habits that operators repeat shift after shift. Because it's a structural problem, it demands a structural solution. Moving on to Section 2, the 3 types of process loss, or as I like to call it, the chain of inefficiency. To stop this invisible thief, we have to know exactly what they look like and where they operate, right? There are 3 main culprits of process loss that we really need to investigate: unnecessary pressure discharge, adding excess chemicals, and the mishandling of semi-products. Each one of these has its own sneaky way of siphoning money right out of your production line. Let's look at that first culprit: unnecessary pressure discharge. Now, obviously, some pressure release is completely required for safety. But when it happens unnecessarily, maybe due to poor calibration or just bad habits, it creates this brutal 3-stage cost trap. First, you lose the raw materials, like the gases or vapors that escape. Second, you waste the expensive energy, like steam or electricity, that was used to generate that pressure in the very first place. And third, you often have to pay environmental treatment costs just to safely handle the gases you just vented. It is literally a triple threat to your bottom line. All right, we need to debunk a massive factory floor myth right now. Operator logic so often says, hey, let's just add a little more chemical to make sure the reaction is stable. Well, it turns out playing it safe like this is actually the most dangerous thing you can do for your budget. Adding extra chemicals doesn't magically increase production. Instead, it directly drives up your material costs, it generates unwanted byproducts that you then have to pay to treat, and it can push the whole process out of its optimal zone, which actually lowers your overall production yield. No way is that a safe choice. Our third culprit is the semi-product. We need a major paradigm shift on how we view these. A semi-product is not just some intermediate halfway there good. If you lose a semi-product, you aren't just losing raw material. You are instantly wasting all the accumulated raw materials, the energy, the machine time, and the labor invested up to that exact microsecond. It's an asset with a near equal economic value to your final product. Losing it causes an immediate hit to your revenue and completely throws off your production schedule. Okay, Section 3, the biggest hidden cost: utilities. We've talked a lot about process. Now let's talk about equipment efficiency. The absolutely crucial point here is that utilities, things like steam, electricity, and water, they aren't just background expenses. They are direct and indirect manufacturing costs. In fact, they're the biggest hidden costs. Think about it. If your equipment efficiency drops, what happens? You end up using significantly more energy to produce the exact same amount of product. Managing equipment efficiency is practically identical to managing your core manufacturing costs. If you aren't tracking your utilities with laser precision, you are literally bleeding money. Which brings us to Section 4, the 3 traits of equipment loss. Let's categorize these thieves. Just like we categorized process losses, let's look at the behavioral profiles of our utility thieves. Take steam, for example. A leaking steam trap, that's a cumulative loss. It seems tiny, but over months, the energy cost accumulation is just staggering. Next, water. Water is a chain reaction loss. If you leak water, you don't just pay for the water, you pay for the extra chemicals mixed into it, and then you pay again to treat the increased wastewater volume. Finally, overlapping energy, like running a heater and a cooler on the exact same line simultaneously. That is an immediate loss. The instant you do it, that energy cancels itself out and the money is completely wasted. Poof, gone. Next up, Section 5, the balance of risk and ROI, the Executive Balancing Act. Now, fixing these issues isn't as simple as just marching out there and turning off valves, right? Management has to navigate a really delicate tension. On one side, you have the intense desire to cut costs and maximize your ROI. But cutting costs too aggressively can actually increase your risk. If you cut steam usage way back, productivity might drop. If you cut cooling too drastically, product quality definitely suffers. But on the flip side, obsessing over risk means you never change anything and you miss out on massive savings. The true goal of an executive here is finding that optimal balance point where you are minimizing waste without sacrificing stability, quality, or safety. And finally, Section 6, executing data-driven cost reduction, the future of optimization. The harsh reality is, human intuition and those periodic walkarounds, they just aren't enough anymore to catch these invisible thieves and maintain that perfect balance of ROI and risk. We need modern tools. The future of optimization relies on a really clear predictive progression. Step 1 is continuous data collection from sensors all across the floor. Step 2 utilizes AI anomaly detection. AI can spot a tiny steam leak or a slight chemical imbalance long before a human operator ever could, effectively predicting the loss before it compounds. And Step 3? Using digital twins to simulate changes without actually stopping production. This lets you establish the absolute optimal operation parameters. We are moving from reactive fixing to proactive, predictive perfection. But listen to me carefully here. Data is completely useless without action. It has to be a continuous cycle. You collect the data, you analyze it for losses, you create an improvement plan, but then, and this is the crucial part, you must execute it in the real world and monitor the results. Execution is the only thing that actually realizes those cost reductions. The factories that win tomorrow won't just be the ones with the flashiest sensors, they'll be the ones that act on their data the fastest. So, I'll leave you with this final thought. What kind of losses are hiding on your factory floor right now? Think about the cumulative steam leaks, those chain reaction water wastes, the invisible pressure discharges we talked about. They are out there, right now, as we speak. Your job isn't just to make a product, it's to actively seek out these invisible thieves and reclaim your efficiency. Take these frameworks, go look at your data, and start making those structural changes today. Thanks so much for joining me for this explainer, and I'll catch you next time.